Hello, in this session we shall continue to look at matrices and transformations. In a previous session I have talked about reflection in the x-axis. So now I'll start with reflection in the y-axis. So we start with a graph with the x and the y-axis. Right, suppose that I have a point here, P, with coordinates, let's say 3, 1, 3, 2. Now if I want to reflect this in the y-axis, we imagine that the y-axis is a mirror and the image of this point P should be on the other side and at the same distance from the mirror. So it would be there, I'll call it P primed, and the x value of P prime should be -3, same distance but on the other side. The P coordinates are 3, 2, and the pre-primed coordinates are -3 and 2. So it's easy to see what the answer is, but we can also find this using a matrix. Right, the idea is that if I start with the coordinates of P and I want to find the coordinates of P prime of the image, the coordinates of P is 3, 2, of P prime is -3, 2. And the idea is that there is a matrix that I can multiply by 3, 2 in order to get -3, 2. And that matrix is this. So you might find it strange, difficult to understand why this matrix will give this answer, or how we know that this is the right matrix to use. Now, two answers to this question. Quick answer is you can just memorize it and take it for granted. The other answer I will explain later or in a following session, how we can actually understand and also derive this matrix. But for now, let us just assume that this matrix is given, or that we remembered it, and we just want to check that when I multiply this matrix by this vector, I will indeed get the right answer. So when I multiply this matrix, I will take -1 times 3, which is -3, plus 0 times 2, and the answer is indeed -3. And if you do that for the next row, 0 times 3 plus 1 times 2, you will get 2. So this is the correct matrix. And if I have a different point with a different coordinate, I can also use the same matrix to get the answer. Let's try another point. Now, how about a point here, a point A, which is at -2 and -2. Okay, and we want to find where the image of this A, I'll call that A prime, where A prime is. So let's start with the coordinate of A, which should be -2, -2. Okay, so from A, I want to find the coordinates for A prime. And A would be -2, -2. And the idea is that I should be able to find the answer using this matrix, -1, 0, 0, 1, and multiply it by the vector for A. So let's try that. When we multiply, we take this row and multiply it by this column, number by number. So we start with -1 times -2, which is 2, plus 0 times -2, which is 0. So 2 plus 0 is 2, and then the next row times this column, 0 times -2 is 0, plus 1 times -2 is -2. So that's the answer, 2 minus 2. So A prime, the image is at 2 minus 2. Alright, 2 is there, and -2 is there. So that's how we can get the answer for a reflection in the y-axis. So next we are going to look at something a little bit more tricky. We are going to look at reflection in the origin. Now the origin is this point where the two axes cross. A reflection in a point, alright? So the origin is just a point. Now we know about reflection in a mirror, which is a plane, you look at it and you see yourself. But what does it mean, a reflection in a point? Well, this is not something we can actually see easily in real life. Now the idea is that in mathematics we think of reflection as something that gives you an image which is at the equal distance behind some mirror. Now in this case, if we imagine that this point, this origin is some kind of a mirror, if I have an object there, let me call it A, then if I reflect it about this point O, my image should be on the opposite side of the point, and it should be at the same distance on the other side. So it should be somewhere there. It's my image. How exactly do we find this point? Well, if I have to draw it, I would use a ruler and a pencil, and I would just draw a line from A to O, and I'll carry on for the same distance. I would just use a ruler to measure that and check that those two distances are equal, and I would put a point there. So it's quite easy if I have to do it using a ruler and a pencil. And if I have another point there, for example, B, I can just do the same thing. Just draw a line and measure out the same distance on the other side of O. So that's what we mean, or that's what we do when we think of reflection at a point or reflection at the origin in mathematics. And what we want to learn now is to how we can use matrix to help us calculate the position of the image. So for example, if I look at B and suppose that the position of B is at 2, 1, and I want to find the position of the image B primed. Now, without actually using any matrix, we can actually find the answer quite easily if we think about the graph and the geometry. See, if you imagine, say, drawing a triangle like that, okay, then when I reflect this in the origin, this triangle becomes that. So I have this triangle gets reflected into that triangle, so the whole thing becomes inverted. B goes to B prime and 2 goes to minus 2. Well, actually we can make it easier. We don't have to think of a triangle. It is just that if B prime is the same distance from O as B is from O, then the x value of B must also be the same distance from O as the x value of the image, because it's symmetrical. So therefore the x value of B prime of the image is just minus 2, and the y value of B prime is just the negative of the y value for B. So 1 becomes minus 1 and 2 becomes minus 2. So the whole thing gets flipped over to the other side of O. So once we see this, we know right away that the coordinates for the image should be minus 2, minus 1. Okay? And if you look at this coordinate, minus 2, minus 1, and that one, 2, 1, you can see that all we have done, or all we really need to do, is to add minus signs to the numbers, right? 2, 1 becomes minus 2, minus 1. And it's quite easy. So now let's see how we can do it using a matrix. And while using a matrix would look a bit troublesome and unnecessary, because if we can do it so easily using the minus sign, why bother using matrices? But as in the earlier examples about matrices, the reason is really to make the calculations easier when you have a more complicated problem, which we will see later on in some examples. So for now, let us use this example to see how we can use a matrix to find the position of the image of B. Right, so B, and the image is B prime, and we already know that the coordinates of B is 2, 1, of B prime is minus 2, minus 1. And now we want to learn the matrix that will multiply by 2, 1 to give the image. And the matrix for reflection in origin is minus 1, 0, 0, minus 1. That is the matrix. And if you multiply this by 2, 1, you will get the answer. So for now, once again, we shall take this matrix as given and assume that we can memorize it and use it to find the answer. And later I will explain how this matrix can actually be understood, how we can actually derive this matrix ourselves. So for now, let's just take this matrix as given, and all we need to do now is to check, to confirm that this matrix gives the right answer. So if I multiply the first row with the first column, minus 1 times 2 is minus 2, plus 0 times 1 is adding 0, so minus 2 plus 0 is minus 2. So that gives us one number. And then if I take the second row and multiply by B, 0 times 2 is 0, minus 1 times 1 is minus 1. So it's correct. If I multiply the matrix and the vector, I get the right answer. So let's just try it with A. Okay. Now suppose the coordinates of A is 2, 3, for example, 2, 3, and A prime is, as we understand from B, we just have to add minus signs to 2 and 3, so it should be minus 2 and minus 3. Alright, so we can already see what the answer is. So we just want to check that if I use this same matrix and multiply by 2, 3, we just want to check that we can actually get the correct answer. Let's try that. A and A prime. So minus 1, 0, 0 minus 1, and 2, 3. The first row times the first column, minus 1 times 2 is minus 2, 0 times 3 is 0, so minus 2 plus 0 is minus 2. Next row, 0 times 2 is 0, minus 1 times 3 is minus 3. We have 0, minus 3, minus 3. The answer is minus 2 minus 3, which is correct. The next part, we'll look at one more type of reflection, that is reflection along a line. Reflection in the y equals to x line. Now the y equals to x line is a line, it's a straight line that goes at 45 degrees through the origin of the graph. So that's our y equals to x line. You can check that by plotting it on the graph paper yourself. Now this line cuts the graph at 45 degrees, so it is symmetrical. Alright, one side looks the same as the other side. So this is 45 degrees and that's also 45 degrees. And we want to look at reflection in this. Okay, so let's start with an example. Let's look at point A with coordinates, let's say 2 and 1. Now if we think of this line as a mirror, we can see that the image should be roughly there. Right? But where exactly is there? What are the coordinates of the image? Again, there's a matrix to get to this answer, but let us try and understand this with geometry, understand how we can actually find the coordinates of A prime. Now the way to work this out using geometry is to imagine a rectangle. This rectangle that I can get by drawing these lines, right? Drawing vertical and horizontal lines from A to the axis. You can see that it forms a rectangle. And to think about reflecting this triangle, this rectangle, in this line. Now to reflect the rectangle, it's easier to think about reflecting the corners of the triangle one by one. The origin is one corner, that's already on the line, so if you reflect, it just stays on the line. Okay? The image of the origin is itself. Let's look at that corner. This point there, which is 2. Now if I reflect this in the line, because x and y, both the x and the y axis are at the same angle at 45 degrees from this y equals to x. So if I reflect this corner, this 2 along the line, the image of this point should be here. Should be at the point 2 along the y-axis. Simply because if I reflect the x-axis along this line, I should get the y-axis. It's because it's symmetrical. So the 2 there would go to there. Alright? Which means that this side, this horizontal side of the rectangle would be reflected to this line. Now let's press on. Let's reflect that corner, the corner 1 on the y-axis along y equals to x. So the 1 would reflect into the x-axis for the same reason. So this 1 goes into the x-axis. So this side, the vertical side of the rectangle, is reflected to this horizontal section. Now let's look at our results so far. Let's look at what we have found. We have reflected this side of the rectangle to that line, and we have reflected this side of the rectangle to this line. So we have just reflected two sides of the rectangle to here. Now once you have two sides of a rectangle, you can easily complete the rectangle by drawing the other two sides. That's our new rectangle. Okay? And therefore, because we know that A is the remaining corner of the rectangle, so its image must be the remaining angle corner of this reflected rectangle. So that's where the image of A is. That's where A prime is. And now, because we already know the sides of this rectangle is 1 and 2, we also know the coordinates of A prime. It is just 1, 2. So whereas the coordinates of A is 2, 1, the coordinates of its image is 1, 2. So we have a simple way of finding the answer. You see that 2, 1 becomes 1, 2. The x and the y values are interchanged. And that's all we need to do when we reflect in the y-axis, just exchange the x and the y value. Okay, and as before, we want to look at how we can use a matrix to find the answer. So starting with A, with a coordinate, the coordinates 2, 1, and the image 1, 2, and A primed. If we want to use a matrix, the matrix is 0, 1, 1, 0. Okay, so again, assume that this is given. Assume that you have remembered this. And we just want to check now that when you multiply this matrix by this vector, you will actually get the correct answer. So let's try that. First row times this column, 0 times 2 is 0, plus 1 times 1 is 1. So 0 plus 1 is equal to 1, that's correct. Next row, 1 times 2 is 2, plus 0 times 1 is 0. So 2 plus 0 is 2. So this is correct. They're equal. Okay, this matrix multiplies to give you the right answer. And the idea is that if I have any other point with any other coordinates, I can get the image position by multiplying it with the same matrix. Now we are going to look at rotation. suppose that we have a point A at this position, 2, 1, and we want to rotate this point about the origin by a certain angle. Now what does that mean? First, draw a line joining O to A. Okay, so imagine that this line is like a piece of like a rod, okay, a piece of rod, and you hold the rod fixed at this end, and you move the other end around by a certain angle. So that's what we mean by rotating A about the origin. So suppose that I rotate it until here, to this point called A prime. If I join the line, draw the line to the origin, and suppose that this angle is 30 degrees. Okay, so if I rotate A by 30 degrees about the origin, I would arrive at this point A prime. And the problem here is to find the coordinates of A prime. So the coordinates of A is 2, 1. What is the coordinates of A prime? This problem here is a bit more difficult than the examples that we saw just now on reflection. It is quite tricky to try and find the answer to this geometrically. We can do it actually using what we have learned from in trigonometry, using sines and cosines. So in this case, I shall not try to explain how to do it directly using geometry and trigonometry. I will go straight to using the matrix. So first, let me call the angle using a symbol. Let me call it alpha. Okay, so in this case the angle is alpha, and alpha is 30 degrees. So I'm just going to write down a formula for the matrix that we need for rotation. The rotation matrix is given by cosine alpha minus sine alpha, sine alpha, cosine alpha. So it's a rather strange looking matrix. What this means is that this is a formula for the matrix, and if, for example, if alpha is 30 degrees, then the four numbers in this matrix you have to find by using this formula. And the first number is cosine 30 degrees, which you have to calculate with your calculator. Next number is minus sine of 30 degrees, and then that would be sine 30 degrees, and that would be cosine that would be cosine 30 degrees. So let's work this out. Let's let's calculate this and find out where that point is, where the image is. So to make things easier, I'm going to start by finding cosine and sine 30 degrees first. Now sine 30 degrees, as I remember from learning about special angles in trigonometry, is 0.5. So if you remember the special angles, you don't need your calculator for this. The cosine 30 degrees, if you remember from your special angles, is actually square root of 3 over 2. Now since I need to do some actual calculations, I shall use my calculator to find answer to this. I'll just whip out my calculator and find answer. I'll press cosine 30 is equal to 0.8660. That's the answer for cosine 30 degrees. So now that we have the values for this matrix, let me write it out. Now the purpose is that we are given the position of A. We want to find the position of its image, A prime, when we rotate by 30 degrees about the origin. And the idea is that we can find it using this matrix. If we multiply this by 2, 1. And this matrix, as I've calculated, is cosine alpha, which is 0.8660, minus sine alpha, which is 0.5, for minus sign. Okay, and then sine alpha here again, 0.5, and cosine alpha there. So there we are. That's the matrix in numbers, and that's the position of A. Now we have to multiply them together. This will be a little more tricky. Let's try it. Now I need to multiply the first row by the first column there. So I start with 0.866 times 2. And again, we can use a calculator. I will press in 0.866 times 2. $1.732. Okay, and then plus negative 0.5 times 1, which is minus 0.5. That's okay, and then we do it for the next row. 0.5 times 2 is 1 plus 0.866 times 1, which is 0.866. Okay. So we can now find the answer. Let's do the subtraction. 1.732 minus 0.5 is 1.232, and 1 minus 0.866 is 0.134. That's right. So that finally is the position of the image A prime. So it's obviously more complicated than the earlier examples on reflection. That's how we find it. But it's not always so complicated for rotation. There are 2 or 3 special cases for rotation which is quite easy, which is just like the reflection examples that we have seen. Let's start with one example. Rotation by (90°). Let's okay. Rotation by 90° about the origin. Rotation by 90° anti-clockwise about the origin. Okay. Look at this example. Okay. So once again, think of a point, let's say A, which is at 2, 1. And we want to rotate this by 90° anti-clockwise. Anti-clockwise means that way. Okay, that's anti-clockwise, and this way is clockwise. Right. About the origin means the origin is there, and I imagine drawing a line joining origin to point A, and I must hold the line fixed at the origin and rotate this line by 90°. So it is somewhere there that I can find the image. And you need to rotate by 90°. That's the angle. So the problem is, what are the coordinates of A prime of this image? Now we can of course use the same formula that we saw just now with the sine and cosine, and then take 90° as alpha, the angle, and you'll find the answer. There is a much simpler way in this example. a bit like the example we saw in for reflection in the y equals to x line. And the simple way to find the answer in this problem is to think about this rectangle like we did just now. If you think about this rectangle, so instead of just thinking about rotating the point A itself, imagine that you rotate the whole rectangle about O. So O, the origin, is one corner of the rectangle. You hold that fixed, but you rotate the whole rectangle by 90 degrees. That's actually quite easy, because if you think about this side, the O1, when you rotate by 90 degrees, the 1 there would just come here to -1, because you have exactly 90 degrees between y and the x-axis. So this side the vertical side becomes horizontal, and the horizontal side O2 becomes vertical, right? Because x-axis rotates 90 degrees to y-axis. So therefore, if we now complete this rectangle with the two new sides, this is what we get. That's a rotated rectangle. And the remaining corner must therefore be the image A prime. Alright, the remaining corner here is A, and A must have rotated to that corner. And since this is a rectangle with the sides at -1 and 2, we have the answer, -1 and 2. Okay, this is A, and coordinates are 2 and 1. So what we see here is that if we start from 2, 1, the answer becomes -1, 2. So what actually happens is that the x value of 2 becomes the y value in the image, and the y value of 1 becomes minus of the y value at the image. So that's one way to think about it. You can just exchange the x and y value and add a minus sign to the new x value. So that's how you can do it. You can do it geometrically in this way. But as before, we need to learn about how we can find this same answer using a matrix. So starting from A and going to A prime, A is 2, 1, and we already know the answer that A prime is -1, 2. We want to learn the matrix that can give that gives the right answer. As I have mentioned, you can get this matrix using the rotation matrix formula that we saw just now, the one that has the cosines and sines. And you can use that formula, set the angle alpha to 90 degrees, and calculate the sines and cosines of 90 degrees. And then you can find the numbers for this matrix. So without actually going through the calculations, I'm just going to write down the answer directly. 0 there and 0 there, and a -1 there and a 1 there. Okay, so those two zeros actually comes from cosine of 90 degrees. And those two ones there comes from sine of 90 degrees using that formula. Now I just want to check that when I multiply this matrix by the coordinates of A, to check that I actually get the right answer. So let's do it. First row, first column. 0 times 2 is 0, and minus 1 times 1 is minus 1. So 0 minus 1 gives 0, which gives minus 1, which is correct. Second row, 1 times 2 is 2, plus 0 times 1 is 0. So 2 plus 0 is 2. Therefore, we get the right answer using this multiplication. There are actually two other special cases, simple cases for rotation, and the other case is when we rotate by 90 degrees clockwise instead of anti-clockwise. So if you imagine, instead of rotating it anti-clockwise that way, we rotate clockwise this way. The picture is very similar. We just go in the opposite direction, and the idea is also very similar. Is we can use a very similar picture, but with the rectangle rotated to the other side. So I'm just going to write down the answer for this. If I rotate by 90 degrees clockwise, okay, then A would come down to here, which is I'm just going to call it B, okay. So what you'll find if you draw this rectangle and rotate it by 90 degrees, the new rectangle will be there, and you find that this side 1 rotates to this side, and this side 2 rotates to this side. But I would have a minus 1 there because it's below the origin. And therefore, we can see now that the coordinates of the image B is minus 2, oh no, is 1 minus 2. Same idea as before. And using the matrix, A goes to B. Alright, so 2, 1 is supposed to go to 1 minus 2. And we want to check this using the matrix multiplication. So we need to first get a matrix. To get this matrix, we could do the same thing, use the formula with the sines and cosines, except that this time the alpha in the formula should be minus 90 degrees. So I must use alpha equals to minus 90 degrees here. Okay. Previously, for that rotation, for 90 degrees anti-clockwise, we would use alpha equals to plus 90 degrees. Okay, that's actually a convention, a way to use the formula. Because by default, the understanding is that a rotation anti-clockwise is a positive angle, clockwise is a negative angle. So if you want to use that sine and cosine formula, you must set the angle alpha to be minus 90 degrees. Okay, and if we apply the formula, we'll find that the answer is a matrix that looks like this. So again, we have cosine of minus 90 degrees is 0, and sine of minus 1 is actually minus 1. So that's what we get. And looks very similar to the previous matrix, except that the signs are reversed. Okay, minus 1 becomes 1 and 1 becomes minus 1. And if you multiply this by this, you'll find that you would indeed get the answer B. Okay, so first row, first column, 0 times 2 is 0, plus 1 times 1 is 1. So 0 plus 1 is 1, minus 1 times 2 is minus 2, plus 0 times 1 is 0, minus 2 plus 0 is minus 2. So we get the right answer. Now we'll stop here for now and continue next time. See you again.